Hi, in this video we are going to talk about how you evaluate trig functions of quadrantal angles. So before we even talk about quadrantal angles, I just want to review an angle on a coordinate plane. So first, what we have is we have the initial side that I'm highlighting here, and then we have some rotation, and we show an arrow, and then we end up at the terminal side. And this would be our theta, the measure of the angle. And in order to do a problem like this, remember, we would actually use the reference angle to figure that out. So if we have, going over to this next picture, if we have an angle with the initial side right here, and if there is no rotation, the terminal side is the same place, and so that's a 0-degree angle. If we have an angle that the initial side is right here, but we have a rotation a fourth of the way around the circle, that is a 90-degree angle. If we have an angle that has the initial side here, and we rotate halfway around the circle, that would be a 180-degree angle. If we have an angle that goes 3/4 of the way, it would be a 270-degree angle. And if we go all the way around the circle back to 0, we rotate 360 degrees. Let me write the right number here. 360 degrees. So now let's review how we found the trig functions, evaluated the trig functions on the unit circle. So first we have an angle. We have the initial side. Let's just make up an angle here. And so this will be my theta. So we picked a point, and it could be on some type of a circle, picked a point on the circle, and we drew a line down to the closest x-axis, a perpendicular line. And to get to this point, we would have to travel along the x-axis, and then we would move up on the y-axis. And so we would have x and y. And then to find the hypotenuse, we would do the Pythagorean theorem. So let's just review here this process, because we're going to use this process when we get to our quadrantals. So c squared equals a squared plus b squared, and we are looking for the hypotenuse. So h squared equals x squared plus y squared. And you are used to doing that with numbers, so we're just using letters here to see how we would do it when we don't have an actual triangle. And so we're going to take the square root of both sides. So h would equal the square root of x squared plus y squared. And so that's how we get our h. Now also keep in mind, when we have to figure out our trig functions, sine of theta, cosine of theta, and tangent of theta, remember I always say label the triangle first. So if this is your angle, straight across is your y, which is your opposite. Adjacent is the x. And then the hypotenuse. And sometimes that's called r for the radius of the circle. So instead of using h, you might see an r. So your sine is opposite over hypotenuse. So it would be y over h. Your cosine is the adjacent, which is x over the hypotenuse, and tangent is opposite, which is y, over adjacent, which is x. These you want to remember when you do quadrantals. So now let's go ahead. You might want to I'll give you a minute to write those down because they're very important. I'm actually going to try to get these all to move down here so we can use them in the next part of the problem here. All right, so let's talk about the quadrantals. The first quadrantal angle is a 0-degree angle. And if this is a unit circle, meaning that the radius is 1 unit, the location of this point would be over 1, up 0. So this is your x, this is your y. Now, if we were going to use, this isn't, it is 0 degrees right here. We don't have a triangle, but using the same idea to figure out the trig functions, we need the hypotenuse. So we would plug the x and the y into this equation. So 1 squared plus 0 squared would be 1 plus 0, which is 1. So your hypotenuse equals 1. Now from there, you can just substitute in the x and the y and the 1 into these equations. So the sine of 0 would equal the ratio y over h. Your y value is 0. I'm getting it from right here, over h, which is 1. So that's 0. The cosine of 0 is x, which is 1, over the hypotenuse, which is 1. And the tangent of 0 is y, which is 0, over x, which is 1, which is 0. And those are your trig functions. If you plug those into your calculator, sine of 0, you'd get 0. Cosine of 0, you get 1. Tangent of 0, you would get 0. So we were able to do this without a calculator. Now, let's take a look at our 90-degree angle. So we'll put a point right here, and the location would be over 0, up 1. So this is your x, this is your y. So again, we have 0 and 1. If we put 0 and 1 into this formula right here, it's going to be the same answer. So your h would equal 1. So if we were doing the trig functions, the sine of 90 equals opposite, or your y, which is 1, over your hypotenuse, which is 1. The sine of 90 is 1. The cosine of 90 is the adjacent, or the x, which is 0 over, 0 over 1, which is 0. And the tangent of 90, tangent is y over x, so it's 1 over 0, and that is undefined. We can't ever have a 0 in the denominator. If you put tangent 90 in your calculator, you would get an error. Now let's talk about 180 degrees. So looking at the location of that, we would have to go back 1, so your x would be a -1, your y would be 0. And again, if you square -1, you'd get 1. If you square 0, you get 0. So the square root of 1 is 1, so your hypotenuse would equal 1. So the sine of 180, sine is y over h, so it's 0 over 1, which is 0. Cosine of 180, cosine is x over h, so it's -1 over 1, which is a -1. And then tangent of 180 is y over x, so it's 0 over -1, which is 0. And lastly, we will do 270. And the location of that is over 0, down 1. And again, if we put this into the Pythagorean theorem, the 0 and -1, your h would be a +1. So the sine of 270 is y over h. So -1 over 1. You get a -1. Cosine of 270 is x over h, so 0 over 1, so it's 0. And tangent of 270 is y over x, so -1 over 0, which is undefined. And then you could also do 360, but it's at the same point as 0, 1, so the answers will all be the same. When you take your test on this, you won't be able to use a calculator, so you have to be able to figure these out. So let's go to your worksheet here and work out a few of these problems. So again, you want to remember that sine of theta is y over h. Cosine of theta is x over h. And tangent of theta is y over x. So if you have to find the sine of 90, put a dot at 90 degrees and write down the point that it would be on the unit circle. So you would go over 0, up 1. So this is your x, this is your y, and your hypotenuse is always 1. So the sine of theta is y over h. So 1 over 1. The cosine of theta is x over h. 0 over 1, which is 0. And the tangent of theta is y over x, which is 0, which is undefined. So again, as you work this out, don't just look at the other worksheet that I did, the notes, and copy down the answers, because you won't have your notes on the test and you will have to understand the process. So we'll just do one more and then you can finish working on this sheet. So let's do, why don't we go ahead and do cosine of 180. So I'll put a dot right here. So assuming a unit circle goes through there, this point right here would be negative 1, 0. Your h is equal to 1. So your sine of 180 would be opposite, or your y, which is 0 over 1, which is 0. Cosine of 180, and I should have written, when I was doing these problems over here, I should have written 90, because we knew the angles. So cosine of 180 would be the adjacent, which is your x, over your hypotenuse, which is 1. So you get a negative 1, and tangent of 180 is opposite over adjacent, which is y over x. So it's 0 over negative 1, which is 0. So finish this worksheet for tomorrow. Thank you.